Welcome to MicroStrategy World 2021. This is the Enterprise Data Track, and this is the Deploying Real-Time Analytics session. My name is Gareth Grange. I'm a Senior Solutions Engineer for MicroStrategy, and today I will be your host for this session. For our agenda today, we will be looking at 4 topics: defining real-time and where it fits into an analytics scenario, how does MicroStrategy support real-time analytics, and how can we integrate into it. We'll be looking at a small demo on a point of sale scenario where we can see how it would work. And finally, we will look at 3 scenarios of how to review your requirements and which MicroStrategy options we can use to build our real-time analytics, as well as a few customer use cases. I'd like to start off with defining real-time analytics and understanding the components of a data pipeline that will be affected by real-time analytics. On the screen in front of you is an example, a very simple example of a data pipeline showing the origination from the source system, the data transfer to the data storage area, the data preparation phase, often known as ETL or ELT, and finally the data analysis phase, which is where MicroStrategy would be used. For the real-time analytics, our focus area is going to be on the data transfer and data analysis components. The data transfer component is critical because that's essentially the first definition of real-time analytics. We're trying to improve the speed at which we can take the data from the original source system and put it into an analytic scenario. So the data transfer is definitely the first phase that we're going to look at. The data transfer component is composed of, well, single or many tools that can be used to achieve this. And these tools have been created specifically for the purpose of enabling real-time analytics. Now, there are many tools out there, and MicroStrategy supports a lot of these tools. But for the purpose of this session, I'll only be discussing one tool. I do recommend, however, that you do go and review these tools and go to their websites and look at the information of the functionality, as there's a lot of different functionality that these tools provide, and many of them could achieve the requirements that you have. For the session today, I'm going to be looking, though, at Apache Kafka, the distributed streaming platform. Now, the reason that I've chosen Apache Kafka for today is, and this might be some new information to all of you, but this is because MicroStrategy actually uses Apache Kafka every day. MicroStrategy uses the Apache Kafka service to transfer logs and to transfer events that are occurring within the system to the platform analytics solution of MicroStrategy, which we use to report on the application. So what is Apache Kafka? For those of you who are not familiar with this technology, Apache Kafka is a solution that allows the movement of data from various source systems to various destination points in a very resilient and scalable method. A simple way of looking at this is to imagine 1,000 or more data points that are all trying to write data to a data storage area. Now, for your traditional data storage areas, this may be a problem because you might have row locks or processes that are preventing that writing from occurring. But Apache Kafka is designed to actually take these, store them, and actually also order them in such a way that they can be redistributed, transferred correctly, and if a failure should occur, that they can retransmit the messages that need to be retransmitted. So Apache Kafka also remembers what messages have been processed so that it can go back to any point in time that it needs to in order to retransmit them. Just to give a basic view of what makes up Apache Kafka, essentially we have a collection of processes that's going to do the work for us. And I've attempted to break it down into a very simplified manner so that you can understand how it would fit into a data pipeline. Primarily, we've got the Zookeeper process, which is the primary controller service. So this is a host service that's going to look after all the other services doing the work. We have the broker service, which is what's going to actually move the data and store it and track where it is. We have a topic, which I like to simplify as a table of data. So we can think of this as, you know, a sales data or HR data or something similar. Then there's the actual message, which equates to a row of data. So again, just looking at maybe sales data, we're now taking individual transactions, and those are the messages that are occurring within Apache Kafka. Then there is the consumer. The producer. The producer is what is actually generating these messages. And this will be the source system that is either generating them and submitting them to Kafka, or the source system where Kafka is retrieving them from in order to store them. And then there is the consumer, and this is what Kafka must do with the data. Where must it actually send the data? And finally, we have what is called the sink. It's the actual process that's going to take the data from the Apache Kafka solution and move it to the consumer. So how does this fit into MicroStrategy? Because we've looked at the fact that we can have multiple tools to transfer data quickly. Now we want to look at what makes up the data analysis component. So once we've covered the speed of getting the data, we now want to look at how we can optimize how we analyze that data. So from a data analytics perspective, and again, this is where MicroStrategy comes into play, we're really looking at three types of analytics. We're looking at historical analysis, which is your traditional BI. We're looking at interval or near real-time analysis, which is situations where that data needs to be processed quicker than our traditional historical analysis. And then we're going to look at real-time analysis, which is at that point in time, that exact point in time, the analysis that needs to occur there. So as I said, historical analysis, that's going to be your traditional data pipeline. That's going to be situations where the data is coming from the system, it's going through a ETL process, a data governance process, maybe even some data management. And then when it's finally ready for reporting, it's analyzed by MicroStrategy for the reporting. For an interval-based or near real-time analysis, we're really looking at improving the data flow, so getting the data, as well as analyzing this. And what we're going to be looking at from an analysis perspective is once we've retrieved the data, how can we minimize the impact of bringing that data into MicroStrategy? And the same thing is how we're going to look at it for a real-time analysis. So we're really looking at if historical is in batch jobs or typically once a day kind of scenarios, your near real-time analytics is going to be quicker than that. It's going to be rated in minutes. So how fast can we get this per minute, and how fast can we analyze this in a minute ratio or 15-minute ratio? And then your real-time analysis is going to be, if this data is coming in a per second basis, how fast can we receive it and how fast can we analyze it? So how does MicroStrategy fit into all of this? MicroStrategy has an open architecture which enables a host of APIs to be available for the processing, retrieval, and receiving of data within the system. In this example, we're going to look specifically at the push API, which is going to enable the Apache Kafka system to take data and push it directly into in-memory cubes within MicroStrategy. The REST API is very powerful in the sense that it provides a lot of functions. And there's two ways that we can achieve receiving data via this. The first one is to use the REST API directly, so to actually access the endpoints of the REST API. And this would mean that there is a system or a third-party application that is going to take the data out of Apache Kafka. It's going to make sure it's in the correct format, and then it's going to access the API endpoints in MicroStrategy to create the data set and submit the data to that data set. Alternatively, using a programmatic language like Python or R, we can achieve the same function by taking the data in those programs and programming interfaces that we've created and actually submitting it to MicroStrategy, again, using the REST API. The real difference between the REST API and the programming languages is the approach that we're going to take. With the REST API, you will have to call each individual endpoint within the actual script or the application itself. But from a Python or R perspective, a lot of these endpoints have been wrapped into code, making it a lot easier to actually get that information. The other aspect to consider with Python and R is that you can also take that data that's coming in programmatically and run it through other Python and R modules to transform it into a specific state for reporting. So there's a lot of flexibility in not only taking the data, but using it for other functions when using it with one of the programming languages. Architecturally, we're going to look at how we can bring this in. And on the screen in front of you is a basic architecture diagram that at first may seem complicated, but really is everything that we've been discussing up until this point. If we start on the left-hand side, you will see there is stream sources. So this may be your programming languages. There may be source systems that are generating events. It's going to be the actual area where the data is coming from. It could even be IoT devices. Moving from that to the stream brokers is where a system like Apache Kafka is going to collect this information, correlate it, and make sure that it's available for our processors that's going to take the information, put it into the correct format that we want, and finally deliver it to MicroStrategy. Now on the screen there, I've also added an extra bit to show that these processors don't have to just deliver it to MicroStrategy. They can continue to deliver it along the normal data pipeline at the same time, meaning that you can achieve your historical analysis flow as well as your near real-time or real-time analytics flow at the same time. Once it's delivered to MicroStrategy, which is through the MicroStrategy APIs, it is a in-memory object that can be used much like you would use it in any other fashion. So you can use that data cube for a grid report, you can use it for a dossier, you can use it for a hypercard through HyperIntelligence, you can use it for mobile devices, you can use it for a host of functions because it's a normal MicroStrategy object that's been created. Once we've got the data in MicroStrategy and we're now storing it in memory, we obviously want to have a way to access that data in an efficient fashion. And so MicroStrategy is going to provide two options to achieve that. We have dossiers with auto refresh, where you can access the information and have it automatically refresh at periodic time frames in order to show the data changes that are occurring. Or alternatively, by engaging our PS professional services team, we can change this to give you a custom visualization that will automatically update within the dossier, requiring less refresh times and more updates of the information. So you've got two approaches to achieve that. Both approaches can be done at a web or mobile level, so you will have flexibility there. But essentially, the real key to take into context here is that once that near real-time or real-time data has been transmitted to MicroStrategy, that you have the ability to interface with it and use that data as you would like to. Just to give you another view of how this would work, it's just a different visual aspect of it. We are looking at here is events from Kafka, so you can see the individual messages coming in a flow type format. We have an application or process which is going to take those messages and it's going to make sure that they're in the correct format for reporting, or it's just going to take them directly as is. And using the REST APIs, we're going to import that into MicroStrategy. And from that, we can build any object that we want to create from a visualization perspective. To explain the API usage a little bit more, I've given this breakdown over here, which will help. The first thing to do is to log in and create a session. And based on that session, you will receive a token, which will be used to access the other data endpoints. This is just to ensure security, and much like all the other objects within MicroStrategy, fits into the MicroStrategy security module, which enables you to establish this from a security role perspective or group or user perspective. This means that you can allocate specific accounts that can access the API endpoints and specific accounts that cannot access those endpoints. Once we've established our session, we do have the option of accessing an endpoint to keep the session alive. This is really useful for situations where you're waiting for data. So you may have a burst of data and then a delay before the next data is available. So we have an API sessions endpoint, which will enable you to keep that running so that as the data is being received at different intervals, you will be able to transfer it to MicroStrategy. So now that we've built the session, the next endpoint is to create the actual model, which is essentially telling MicroStrategy that we would like to create a data set to upload the information into. Once we've created that data set, we now go through the upload session information to actually transfer the data. And once we've established that it is all correct, we have the option to log out and either recreate that process on the next request, or as I mentioned earlier, we can keep that session alive and reuse it for the next request that comes in. How does this look from a Python perspective or R perspective? It very much is following the same requests, but it's just doing it from a programmatic perspective. So All the requests that we've done in the actual REST API will be reused here. We're just doing them in a different fashion. So with this, the programmatic way is, again, to connect to the API. We're going to create a session. We're going to define our data set. We're also, and this is slightly different, we're going to tell how that data should be updated. So we're going to say whether it should be new data, replacing data, or deleting data. Now, just to put that into context, it's not to say that that is not available in the REST API. This is using the REST API endpoint. So both facilities take that into account. You can define both type of policies in the REST API and the Python or R modules. And then finally, once we've uploaded the data, we then publish the cube. The other thing that I'd just like to bring into context regarding Python and R is that although it uses the REST API, a lot of optimizations have been built in, such as reusing the session and optimizing the way that we transfer the data. So it really is recommended as an approach to looking at how we achieve this. And just to give some further context on it, it is also the mechanism that we use when we are doing our data science modules using Jupyter Notebooks or RStudio in order to transfer the data. So we have been using this for a long time, and we have optimized it for the data transfer process. So in summary, if we look at how the two components fit together, we've got the data transfer process, which we want to optimize for real-time analytics. This will be using third-party applications or a programmatic script in order to achieve this. And this data will be pushed to MicroStrategy using these third-party applications or scripts. From a MicroStrategy perspective, we will store the data in memory in Cube to make it as fast as possible. You can use it once it's in MicroStrategy as a report, as a document, as a dossier, as a hypercard. So you've got various options. You can use it in web or mobile. You can also access these via the MicroStrategy app once they're created as objects. So you've got a lot of flexibility there as well. And then there are two options for automatically refreshing the data in the user interface. The first option is to use the automatic refreshing dossiers. The second option is to have a custom visualization that is going to automatically update within the dossier as well. So now I'd like to show you an actual streaming solution in action. So we're going to look at an actual demo of point of sale information that is going to come through an Apache Kafka solution and be pushed into MicroStrategy into a dossier. So on the left, you will see the actual events occurring within Kafka. So you'll see them updating as the events occur. And as those occur, there is a process running in the background that is taking them and pushing them in memory into a MicroStrategy cube. That cube is going to surface a dossier as well as a hypercard that we can use outside of MicroStrategy for specific KPI information. The dossier is set to automatically refresh and will update periodically. But what is nice about this dossier is that we're also using MicroStrategy functions that you would use every day to help us with visualizing the information that we're receiving. So we'll be using the KPI metric, which will help us understand the variations between the messages that it receives. We'll be using thresholds to understand whether we have met the sales targets. And as you will see on the screen, as it updates, we will be able to see the changes occurring. We can also use the MicroStrategy collaboration feature to communicate events as well within the system as they are occurring. So it's not just that we're using this for maybe display purposes, but we can use it to communicate as well within MicroStrategy. As this data is updating, the cube is being updated by Apache Kafka. And in the background, this means that any object that uses this cube can access the data. So the hypercard that we have built within the solution will also have access to the same data that the dossier is going to have. It's just a different view of it. And what I'm going to do is speed up this video just a little bit so that I can show you the changes in the data as it occurs within the dossier. So you'll see there's a lot of changes coming through. We can see the variance. I'm just checking that the hypercard is updated. So just checking the last refresh time. The HyperCard will automatically update every 5 minutes. So it's not something that I have to do manually every time. I'm just doing it for this demo over here. And I can see that the HyperCard is updating correctly, automatically in the background. And just to take you forward a little bit so that we can look at the thresholds. Here we can see that the data is continually updated in the background. And if we go back to the dossier, we will start to see that as the information is changing and it is reaching certain thresholds within the data, we'll see that the dossier thresholds are going to change as well. So we can see that this live data is affecting the information and it is updating according to that information and changing our view of the data. So I'd like to give you a little bit of information regarding how this demo was built. So on the screen in front of you is the actual cube structure that was used. You can see that it is a combination of different types of data. We have static data, we have a daily update data, which would mimic the historical analysis information, and we have live data that's occurring. So this cube does not only have to have live data, it can have a combination of data from within the system. From a performance perspective, I've just included this aspect over here as well. This is on the screen here is the batch size, i.e. the amount of data that is being uploaded to MicroStrategy and the number of seconds it takes to upload at that time. And we can see that MicroStrategy remains very responsive with regards to the size of the data being uploaded. And it's only once we breach around 100,000 rows per upload that we start to see any degradation occurring. So we know that we can take a large amount of data per upload and transfer that to the system. In addition to that, we would want to look at how many systems can upload data at the same time and the size of that data being uploaded. So that's what this view is over here. It's a collection of messages that is increasing per run. And as they increase, we track the amount of time that it takes to actually process that and put it into MicroStrategy. And again, it takes many thousands of simultaneous uploads in order to start degrading the system before it actually causes a problem. For the last section, I'd like to just discuss how to look at your real-time analytics requirements and what choices to make within MicroStrategy to use it. The first scenario I'd like to look at, and it's very similar to the demo that we just saw, was a point of sale solution where you have multiple stores all distributing information into MicroStrategy. They're sending updates as the events occur, and there is a requirement to view that data at different times. So the transfer of the data must occur within 5 minutes, and the consumption of that data means that that data must be available to the end users within 15 minutes of the event occurring. In this scenario here, we do not actually need to use a real-time solution or REST API from MicroStrategy to achieve this. By using our current schema-based reports or by using a Live Connect cube, we can achieve the same function just using schedules and by using our current objects within MicroStrategy. So we don't always need to go the route of changing things within our organization in order to achieve faster delivery and analysis of information. For scenario 2, we have real-time aggregated data coming through. This is being transmitted by an existing Kafka solution. So this is an existing application that's running in the organization. The problem is that the current data pipeline is only available every 4 hours. And what they really need is to have it within 5 minutes for the staff that are actually processing the claims. And they need it every 30 minutes to provide an aggregated view of all the staff activity every 30 minutes. In this instance here, because we have an Apache Kafka already being used, we would definitely look at using either the REST API or the Mysterio Python module, which is the MicroStrategy Python module, in order to take this data and transmit it immediately within MicroStrategy. From an aggregation perspective for the managers, we would create a cube that would aggregate the data, and a dossier that would fulfill the visualization request. And for the claim associates, we would use something like HyperIntelligence to display that data as quick as possible within the application that they're working with. That would achieve their 5-minute window for analyzing the data. A third scenario, which is becoming very common, is the ability to detect anomalies in the data. So as transactions are occurring across multiple systems, there is a requirement to check if any mistakes have been made. Maybe there's fraudulent activity, anything that basically does not meet the business logic that has been defined. So in this scenario, we're really looking at saying, we want to understand what is happening with the data within a very short amount of time. So we're talking within a 60-second time frame over here. So this is definitely a real-time scenario. And in this instance, our solution that we would prefer is to use a REST API or Python module to transfer that data to MicroStrategy, and then to use a solution like MicroStrategy Alerting, where we can apply logic to the data coming in and see if there's any errors or alerts that need to be generated. Alternatively, we can use it for any analysis that we would like to do from a dossier perspective. I'd also like to just touch on two actual customer use cases where it's being used right now. The first one is Fanatics. This is a business that is really seasonal. So they've got situations where they have slow periods and they have periods of the year where there is intense activity. So during the slow periods, they can really use historical analysis to make business decisions. But when they are in certain seasons of the year and those events are occurring every second and they need to make decisions on when to deliver new stock, what stock to order, which areas are critical, they need to be able to take that information and really use it immediately right away. So this is an example of where real-time data can be moved to MicroStrategy and analyzed in a real-time fashion for the business decisions to be made. In a very similar scenario, although this one is slightly different, this is a mobile view of real-time data. So again, a retail type scenario, but it can be used for financial type information. It can be used for inventory, it can be used for a host of other information. But just to show that real-time information can also be used in a mobile perspective, and you can define it against, again, real-time data versus non-real-time data. So you can use it to do benchmarking, target analysis, and review the state of your business as it's occurring at that point in time. Just some final thoughts is that MicroStrategy has a few examples that you can see on the internet that are available to you to go and review how MicroStrategy can be used with real-time data. We have also put a collection of links that are available to help you kickstart your real-time analytics requirements, where you'll be able to review not only some of the basics around the functionality, but to look at MicroStrategy modules, understand how they work, and also the REST API. That concludes the session for today. I'd like to thank you all for your time, and I hope you have a great day.